Hey Professor, this is Rob Hines, and this is my video submission for the Homework 5 assignment. Okay, so for part 1 of this problem, it asked us to solve the system using the contour plot. So here's my code for the contour plot right here. And then this is the actual contour plot in and of itself right here. Okay, so in terms of the contour plot in response to the problem statement, basically the red line, this red curve here, this represents the first equation we see right here. Then we have the blue line here. This blue line represents the second equation here in the middle. And then we have this green curve, this green line here. This green line represents the very last equation right here. So basically, what this contour plot does is it gives us a visual solution of the three nonlinear equations here. And then each intersection between each line, basically these are the solutions, but they're pretty broad general solutions. So that's why we needed to execute these methods right here to find an actual numerical value. Okay, so for this problem, for problem 3, we have 5 different parts. Part 2, 3, and 4 all ask us to use different methods to solve the system here. So for part 2, they asked us to use the Gauss-Seidel method. For part 3, they asked us to use Jacobi's method. In part 4, they asked us to use Newton's method in addition to Gaussian elimination. So here's my work for the respective parts. And I'll zoom in so you can see them more intricately. So for part 2, this is my work for the Gauss-Seidel method. For part 3, this is my work for Jacobi's method. Then for part 4, this is Newton's method. All my work for that method right there. Okay, so what part 5 asks us to do is it asks us to solve the system using MATLAB's fsolve function. So here's my code for part 5, and then I'm going to go into explaining it. So what line 1 does is it just clears everything out. It clears the command window, it clears the workspace, and all of that. And then what this segment right here does, I'm trying to focus. What this segment of code right here does is basically defines this function msystem, defines the msystem function, and then it takes a vector and it uses that vector as the input. The vector is just as x, y, and z vector. And then basically what this does is it computes the system of nonlinear equations, then it gives us a vector back. Then what this line 13 does is it just creates a initial guess for us so we can use Newton's method. Then we have this segment of code, lines 15 and 16. Basically what line 15 does is it just gives us a structure to show our iterations. Then what line 16 does is it uses the fsolve function and it uses the fsolve function to find the root of the MySystem function. And then this last segment here, lines 18 and 19, basically what this does is creates a label, then it gives us the results. It's line 18, and then line 19, it just shows the values for X, Y, and Z in the command window. So in summary, once again, what the code does is it just defines a nonlinear system of equations, then it sets our initial guess for X, Y, and Z, and we use fsolve right here, and we do iterations to find the numerical solution, and then, as we said, finally what it does is it displays the solution in the command window.